Today we're going to break down bloodstain pattern analysis. This is one of the most powerful tools we had to reconstruct what's happened at a crime scene. A lot of people think bloodstain analysis is just like looking at planters and guessing what's happened, but it's actually a science based on physics and fluid dynamics and careful observation. We can tell things like how a wound was inflicted, where the victim and attacker were positioned, even how many times someone was attacked, all from the way blood landed on the surface. We've started with the basics and worked our way up to more complex patterns. We've set up some demonstration here to show exact how different forces create different patterns. So let's start. Bloodstain pattern analysis is a scientific method used to reconstruct crime scene using physics and fluid dynamics. It helps determine how wounds were inflicted, the positions of those involved, and the number of loss. Basics of bloodstain pattern. Mechanical quotient. Blood is a non-Newtonian fluid. Passive stain are created solidly by gravity. Single drop. Gravity pulls blood into a sphere. Higher heights create larger stain due to increased momentum. Drop series combines gravity with horizontal movement. Spacing indicates speeds and direction. Flow pattern. Flow pattern. Blood moves down inclines. Stiffer angles create faster, narrow flows. Blood pool. Blood spears until balanced by surface tension and friction. Shape indicates if the surface was level or moved. Physics of fluid dynamics. Surface tension keeps drops spherical in the air and creates smooth edges. Air resistance affects draft falling from greater heights, slightly flattening them. Kinetic energy increase with height and mass, causing stain to spear wider and form spines or satellites. Environmental factor. Smooth, non-porous. Sharp, clean edges. Raw, irregular, jagged edges. Porous, absorbent. Fuzzy edges. Larger appearance due to absorption. Forensic significance. Size indicate the height of fall. Spacing indicates movement speed. Direction indicates flow and travel path. Shape indicates position of the victim and whether movements occur after bleeding. Types of bloodstains. Passive bloodstains caused by gravity alone, example, drops, loss in pools. Projected bloodstains created by force greater than gravity, like impact splatter, low velocity, large drop which is negative 4 cm, minimum velocity, minimum drops of 1 to 4 cm, then blunt force stabbing, high velocity, mills like 1 cm gunshot, cast off of blood, blonde from a swinging weapon, arch indicate direction and number of blows. Transfer bloodstains create when a bodily surface touch another, like contact, clear impression, handprint, shoeprint. Swipe, bodily object moves across a clean surface. Wipe, object moves through an existing stain. Surface texture. Compare how blood looks on smooth, rough, and absorbent materials. Draw from the same height. Falling distance. Test how stain size change when dropped from different height, like 1 feet to 4 feet. Stains grow larger until terminal velocity is reached. Angle of impact. Formula. Sin, the angle, and width, or the length and the width. Rule 90-degree circle, lower angle ellipsis. Reminder, tip, do not include the tail where measuring length as it will screw the calculation. Source reconstruction. Area of convergence 2D. The point on the surface where stains originate. Area of origin or 3D. The exact location in the space where strings and geometry to determine height. What is the importance of the area of convergence? The area of convergence is the point on a two-dimensional surface where lines drawn through the long axis of individual bloodstains intersect. Its importance lies in the establishing critical spatial relationship at the crime scene. What is the importance of the axis of origin? The axis of origin, also called the line of light, it is three-dimensional path of blood droplets travels from its source to target surface. It combines the horizontal direction from the area of convergence and the vertical angle of the impact. It's important to stems from its role in calculating premises spatial dynamics. Together, this transformation scattered stains into a detailed map of events, revealing everything from the positions of those involved at the crime scene or at the sequence of the action. This information is not just useful for solving crimes. It ensures reconstructions are based on scientific facts rather than speculation, making it reliable evidence in the court and critical for delivering fair justice.